My goodness, what a question for the last in this series of 101 questions. The figure shows three identical rectangles. The shaded areas where the rectangles overlap form squares of 25 centimetres squared each. And we're asked to find the perimeter of the whole figure and to find the total area of the unshaded parts. Okay. So hopefully you did all of the geometry questions in this series. And if you did, you'd have a good understanding of what the perimeter must mean and also what the area is. But let's just go over that quickly. What's the perimeter? Well, that's like the outside border of the shape. So let's say if I started here, maybe I should use another color. If I started here, we would be going along here, down here, here. There we go. There we go. And again, along here. This one, that one, there, there, and there. It's the perimeter of the whole figure. Okay, this whole figure, it's not the inside bits, it's just all of these outside lines. And when I say just, I mean there's enough of them, aren't there? And we are just going to have to use the clues that they've given us to calculate what all of these perimeters are. Now, the first thing we are going to need to do is to figure out how long these sides are. Can you see we've got these squares? And what do you remember about squares? Squares are shapes with four sides that are equal. And we are given the area of these squares. And we can tell, we're told that it's the area. And it's this centimeters squared that tells us the area. And the area of a square is length times breadth. Okay, so area equals length times breadth. And that's going to give you, and if it's in centimeters, it's going to give you an answer in centimeters squared. Now, what we have here is an answer that's 25. And the thing about a square is that the length and the breadth are the same. So we have to think of what number, okay, what number multiplied by itself is going to give us 25. And hopefully you know your square numbers and basic times tables. You will realize that 5 times 5 gives us 25. So we can calculate that each of these squares, okay, has a sides of 5. Okay, these are all 5. And that is going to help us a lot. Okay, so let's look up here. We know that this length is 13. And if this length is 13, then from here all the way to here must be 13. Now, we want to know what this is. So this must be 13 minus 5. So what's 13 minus 5? Well, that is 8. So we know that this length here is 8. What about this up here? Well, we know that this side, the breadth of this rectangle is 9. Okay. So this must be 9 as well. All right. But here we've got 5. This isn't part of this line. So we want 9, take away 5. What's left? We've got 4. Okay, so this side is 4. This is 8. And look, we've got the same thing happening here. So this is 4 and this is 8. All right. And then we've got the 9 and the 13 again. And again, we've got that same situation. This is 5. This total is 9. So again, we've got 4 and we've got 8 and we've got 4 and we've got 8. And I think we have got a value for each line of our perimeter, haven't we? Okay, so what we're going to have to do is just simply add them all together. And what we would do is just go around, pick somewhere to start and just go around and add them all up. So 13 plus 9 plus 8 plus 4 plus 8 plus 4. I think we can just make it a little bit easier because we can see that we've got 8 and 4 here. Okay, this is obviously 12, and we've got groups of these, haven't we? So that's 12. That's going to be another 12, and that's going to be another 12. Okay, and so what have we got? We have got 2 13s. All right, I'm being a bit naughty here, not going around in order. 2 13s and 2 9s at the ends here. All right, because it's a pattern, I can do it this way. Normally, you would just go around and count up all of the lines. So we've got 2 13s plus 9, and then we've got this plus 12 plus 12 plus 12 plus 12. Okay, if I just wrote them all out, it would just take forever. Okay, and then we can just make our adding up a little bit easier because 2 13s is going to be, maybe I can use another color. So 2 13s is going to be 26. We've got 2 9s, that's 18. And we've got 1, 2, 3, 4 times 12, which is going to be 48. Okay, and now we can just add those up. All right, so we've got 48, we've got 18, and we've got 26, and we're going to add them up. So 2 8s are 16 plus 6 is going to give us 22. And then, all right, so that's 6, 7, 8, 9. So the total is 92 centimeters. Keep in mind what it is that you're doing. We're measuring up lengths measured in centimeters. So the perimeter of the whole figure, okay, I believe that it is 92 centimeters. Okay. And if you did it one bit by one bit by one bit, that's absolutely fine. And I admire your patience. Okay. Right. Find the total area of the unshaded parts. Okay. So area, what is area? Well, we mentioned here area. So area, okay, is length times breadth. Okay. And the unshaded parts are these bits here, okay? And often when you've got questions like this and you've got shaded parts and unshaded parts, what you do is you need to have find out the area of one part and subtract the area of the part that you don't want, okay? Now, the way we can think about this is we've got 3 triangles, all right? Let's call triangles. I keep calling rectangles triangles today. So here we go, 3 rectangles, and we're going to call them A, B, and C. Now, let's have a look at them. Let's look at A. We've got A is one of these triangles. There we go again. One rectangle, and what we want to take out of it is one of these shaded squares. Okay, so it's one of our rectangles, take away a shaded square. For B, we've got one of the rectangles, take away 2 shaded squares. And for C, we've got one rectangle, take away 1 shaded square. So actually what I noticed that A and C are going to have the same area. Okay, B has a different area. So we've got A, we've got B, and we've got C. So let's look at A. We need the length times the breadth of the whole rectangle. So where shall I do that? So we've got 13. So this is the whole. All right, I'm going to call that the whole. So we've got 13 times 9, okay? And 13 times 9 is going to give us 117 centimeters squared, because this is in centimeters. So actually, I can use this for all of our calculations, right? Because all of these rectangles are the same. Now, for A and for C, I need to take away the area of one of these squares, which we already know is 25 centimeters squared. So I'm going to do 117, and I'm going to minus 25, and that gives me 92 centimeters squared. So that is the area of A and also the area for C. So I'm going to write that in here, 92 centimeters squared, and that's also going to be 92 centimeters squared. And then B, I need to start with the area of the white triangle and then take away 2 of these 25s. So I could just take away 50 from this, or another 25 away from this. It doesn't matter what I do. They're both the same, but let's say I start with the 117 again, and I subtract 50, which is 25 times 2, right? 2 of those, and 117 take away 50. That's going to leave me with 67 centimeters squared. So that's 67 centimeters squared. And what was I asked to do? I was asked to find the total area of the unshaded parts. So I need to add those all together. And if you add them all together, you are going to get 251 centimeters squared. And that is our final answer for the final question in this mega series. So that's 251 centimeters squared. Make sure you have in the correct units. If it's an area, it must be whatever units you're using squared.